This video is on section 3.2 notes, perimeters of polygons and area of quadrilaterals. So first we're talking about polygons. A polygon is a closed figure containing 3 or more angles and bounded by 3 or more straight sides. So here you can see several examples of polygons. You can see that they have 3 or more straight sides, not curved, and that they're closed figures, meaning there's no openings, and that they have 3 or more angles. And here we have some examples of non-polygons. These are not, they have curved sides. None of these have openings. They're all closed figures, but if we had one with an opening, that would be a problem as well. In a polygon, you have a vertex if you're talking about one of them, or vertices if you're talking about more than one. This is the point where the sides of a polygon intersect. You can think of it as a corner. They are named using the letter they are labeled with, such as A. So vertex A, vertex E, vertex D, vertex C. The sides are the line segments which create the polygon. They are named using 2 letters such as AB. So this is side AB, side BC, side CD. Third, we have diagonals. Diagonals are line segments which connect non-consecutive vertices. Non-consecutive means vertices that are not next to each other. They are named using 2 letters such as AC. So AC is a diagonal, AD is a diagonal, AB is not a diagonal because AB is a side. AE is not a diagonal because it's a side, but any of the other ones are considered diagonals. So if we look at this polygon down here, we're going to write the name of it, and then we're going to write each vertex, each side, and each diagonal. So we can call this polygon UVWXYZ. So typically you use all of the letters of the vertices, often in alphabetical order, and you can use polygon as the more general name, or since this has 6 sides, you could call it a hexagon. Hexagon UVWXYZ would be another good name for it. The vertices are just the names of each of the corners. So each of the points out here. So U, V, W, X, Y, and Z. The sides are each of the line segments. So U to V, V to W, W to X, X to Y, Y to Z, Z to U or U to Z, it doesn't matter. So you'll find that oftentimes people tend to put these in alphabetical order. However, you could switch them and it's still right. So I could call this side VU, WV, XW, and they're still the same. So you don't have to list them both ways. They're still the same if you switch the order. For the diagonals, UV is not a diagonal, but UW, UX, and UY are. So UW, UX, and UY are all diagonals. UZ is not, that's a side. VW is not a diagonal, but VX, VY, and VZ are. So VX, VY, and VZ are all diagonals. WV is not, but WU, we already wrote that one down, but that's a diagonal. WZ and WY. XW is a side. XV is a diagonal we already wrote down. XU is a diagonal we already wrote down. XZ is another diagonal. And then we have YZ is not YU, YV, YW. We already wrote down all three of those. And then ZX, ZW, ZV. We already wrote down all of those. So the diagonals, you can kind of go systematically around to find all of them, but you'll get to a point where they start to get redundant. So here's the name of the polygon, vertices, sides, diagonals. All right, the perimeter is the distance around the outside of a polygon. So here we have polygon KLMN. This is, again, like the general name for this polygon. It's got 4 sides, so I could also call it a quadrilateral. Quadrilateral KLMN would be another good name for it. So the distance around the outside of this polygon, I'm just going to add the lengths of the sides together. So 8 and 10 is a length of 18 inches around for the perimeter. Be careful, it's important that all sides be expressed in the same units before calculating the perimeter. That's something to be aware of, so you don't accidentally add up feet and inches together and get the wrong measurement. Next, we're going to talk specifically about quadrilaterals. So a quadrilateral is any 4-sided polygon, and then we get more specific with our quadrilaterals. A parallelogram is a specific type of quadrilateral, and it's a type of quadrilateral where the 2 opposite sides are parallel. So the top and the bottom are parallel, the left and the right are parallel, and the 2 opposite sides are equal in length. The top and the bottom are the same measurement in length, the left and the right are the same measurement in length. And then you can get even more specific. A rectangle is a type of parallelogram, which is a type of 4-sided shape, where all 4 angles are right angles. So the top and the bottom are parallel and the same length. The left and right are parallel and the same length, but we've added something else. We've added that each corner is 90 degrees. We can get even more specific. A square is a specific type of rectangle, which is a specific type of parallelogram, which is a specific type of 4-sided shape, where all 4 sides happen to be equal in length. So those are all just getting more and more precise with our language as we label these 4-sided shapes. And then we have a trapezoid, which is not a square, is not a rectangle, is not a parallelogram. A trapezoid is a specific type of 4-sided shape. It's a specific type of quadrilateral where it has 2 parallel sides and only 2 parallel sides. And the 2 parallel sides are not equal in length. So you might see them like this, where they're the top and the bottom, or you might see it like this, where they're the left side and the right side. So you're always going to see 2 parallel sides and then 2 non-parallel sides. All right, so down here, they're asking us to classify the shape and be as specific or as precise as possible. So all of these are 4-sided shapes, which means that all of these can be called quadrilaterals. But I want to get more specific as I can. So is it a quadrilateral that is also a parallelogram? Well, call it a parallelogram. That's more specific. So that's what we're going to do, is label them. So here I can see this one. This is a square. That's pretty specific. This is a quadrilateral, but I can see that the 2 sides here, they said, are parallel to each other, and so that makes this a trapezoid. Here we have a quadrilateral where the opposite sides are equal in measurement, and it looks like the opposite sides are parallel. So I'm going to call this a parallelogram. Over here we have a 4-sided shape. It doesn't look like these are parallel to me. This is just a 4-sided shape, so I'm just going to say this is a quadrilateral. So saying that it's 4-sided is as specific as I can get. Over here, I have opposite sides that are equal in length and opposite sides that are parallel. I could call this a parallelogram, but the more specific word here is rectangle because the corners are right angles. They're 90 degrees. So rectangle is more specific. All right. On the next page, we have the area and perimeter of a rectangle. So we're going to find the area and the perimeter of rectangle EFGH. So just like I talked about on the previous page, you can be more specific here. We can call this rectangle EFGH, or I could call it polygon EFGH, or I could call it parallelogram EFGH. All of those would be right. So area and perimeter. The area is the length times the width. So 9 times 5 is 45. And we had inches times inches. And so that makes this inches squared. For the perimeter, we have 2 times the length and 2 times the width. And so that's 18 plus 10. So this is 28, and it's inches plus inches, which is just inches. So we have an area, inches squared, and we have a length, which is just inches. Next, we have a rectangular opening, 12 inches long, must have the same total area as 2 smaller rectangular vents. So I'm assuming this is talking about some sort of vent. Some sort of opening in something, and it says 12 inches long. Okay, and there's 2 smaller vents which measure 6 by 4 and 8 by 5. So the same total area as 6 by 4 and 8 by 5. So 24 plus 40. So 64 square inches. So this area of these 2 vents has to be the same as the area of this one vent. This has to be the same as length times some width that we don't know. What must be the width of the opening? So I'm going to go ahead and do 12 times width equals 64. I'm going to divide by 12. 5.3 repeating. And 0.3 repeating. I'm going to minus off the 5. So I just get the 0.3 repeating. If I hit the math button right here, if you have the same calculator as me, it'll tell you that's 1/3. So 5.3 repeating inches, or 5 1/3 inches is how wide that opening should be. All right, next says find the perimeter of a rectangle whose length is 4 foot 6 inches and whose width is 3 feet 3 inches. So the perimeter, we have the length is 4 foot 6 inches and the width is 3 feet 3 inches. So for me to deal with this, I have 2 units. I'm going to write this as only feet. So I'm going to say 4 feet, and then the 6 inches is 6 inches out of 12 inches for a whole foot. So 4 feet and then 6/12 of a foot. 3 feet and 3/12 of a foot. So we have 2 ways we can type this into our calculator. On these calculators, if you hit the green button and then the equals, you can go down to the second option and you can type in the whole number and then the fraction. So 4 and 6/12 is 9/2. And then if I hit the math button and go down to decimal, it will tell me that that's 4.5. hit the math button, go down to the second option, 3 3/12, hit the math button, go down to decimal, 3.25. If you're working with a scientific calculator, you might be able to just look for a button that looks like that. If you're ever unsure of how to use your calculator and you have one that's different than me, just send me an email and I can either talk you through it through the email or we can meet on Zoom and I can help you with it that way. Or in person is fine too. All right, so I'm going to go ahead and do the perimeter formula. So 2 times the length plus 2 times the width. And this is feet, and this is feet, rather than have feet and inches, feet and inches. So I have 15.5 feet. Or if I want to convert this back to a mixture of feet and inches, I could minus off the 15, and that's 0.5. And then I would take the 0.5, so I'd have 15 feet. And then the 0.5 I'm going to multiply by 12 inches per foot, and I get 15 feet 6 inches. All right, next. It says find the area and perimeter of the square. Okay, so area and perimeter of a square. Area is the side times the side. Perimeter is 4 times the side. So we have the side is 3 feet 4 inches. So that's 3 feet and 4 out of 12 inches. So I'm going to hit the math button. It said 10/3. I'm going to hit the math button and turn this into a decimal. 3.3 repeating. Put a little line over the top. That means repeating. Okay. And a lot of times, well, I'll go ahead and do it this way. So it says for area, I'm going to do side times side. So 3.3 repeating times 3.3 repeating. And then for the perimeter, it says 4 times the side. So 3.3 repeating times 4. And it says round to the nearest 1/10 of a foot. So that's 1 decimal place. Okay, now here, because this is not a nice decimal, I'm going to have to use this when I do my calculation. So I don't want to type 3.3 times 3.3. That means I rounded my answer and my new answer is going to be pretty far off. So I'm going to go up here and make this dark so that I'm copy pasting. 3.3 repeating, I'm going to multiply, I'm going to go up and copy paste. And I believe you should still be able to do that with your scientific calculators. If you're not, you can Google it, you can email and ask me questions. All right, so 11.1, if I round to the nearest 1/10. And this is area, so this is feet times feet, which is feet squared. Okay, and then for the perimeter, we're going to do 4 times the 3.3 repeating. Copy paste. 13.3. And this is feet. So feet squared and feet for our units, area and perimeter. All right. Next problem says find the side length of a square whose area is 927 inches squared, round to the appropriate number of significant digits. So here we're going to use this second formula. It says if you have the area of a square, then to find the side, you can just square root the area. So the side is the square root of the area. The square root is right here in blue. So I'm going to hit blue and then that button. Square root 927. And our number here had 3 significant digits, so we get 3 significant digits. 1, 2, 3. The 4 is followed by a 4, so I'm going to keep it the same. 30.4. inches. All right, now we have the area and perimeter of a parallelogram. So you'll notice here they didn't say length times width because that's not quite what this is. It's the length of the base and then the length of the height. And the height is kind of like the width, but not quite. The height is the distance from the bottom to the top. Okay, so base times height, and then the perimeter is just around the outside, like we did before. So let's find the area and perimeter of each parallelogram. So we're going to do the base times the height. 7 times 10 is 70, and it was inches times inches, so that's inches squared. And then the perimeter is 2 times the length of this side plus 2 times the length of that side. So 2 times 7 plus 2 times 12.2. So 14 plus 24.4 is 38.4 inches. Okay, and then over here we have the area is the base times the height, centimeters squared, because we have centimeters times centimeters, and then the perimeter is 2 times 18 plus 2 times 24, so that's 36 plus 48, and that gives you 84 centimeters. Okay. All right. For a trapezoid, the area of a trapezoid is base 1 plus base 2, and they call the two different bases those two parallel sides. And even though they call them bases, they won't always be the top and the bottom. Like in the second picture, the parallel sides are not the top and the bottom. Okay, so base 1 and base 2 are the parallel sides, and then the other sides are the non-parallel sides. So the height is the distance between the bases. So base 1 plus base 2 divided in half, multiplied by the height. Okay, so here we have the area of this trapezoid is base 1 plus base 2 divided in half, multiplied by the height. 19 plus 7 is 26. 26 cut in half is 13. So we're doing 13 times 6, and we get 78 inches times inches is inches squared. Okay. Here we have all sorts of fractions, and if you want, you can rewrite all of these. I know that 6.5 is 6.5. 9.5 is 9.5. 3 3/4 is 3.75. 2 1/4 is 2.25. So the area for this one is going to be base 1 plus base 2 divided by 2. Multiplied by the height, which is 2.25. Okay, so 9.5 plus 6.5, so that's 10 plus another 6 is 16 divided by 2 is 8. 8 times 2.25 is 18. 18 inches squared. Okay, and then for each of these, we need to find the perimeter, and there's no formula for this. We just need to add up all the numbers around the outside. So the perimeter is 8 plus 7 plus 9 plus 19. 43 inches. The perimeter is 9.5 and 6.5 and 2.25 and 3.75. $22. All right, and here are some application problems. So it says, what is the cost of fencing a rectangular playground that measures 45 yards by 58 yards at a cost of $16 per foot? So if it's fencing, we're not talking about area. We must be talking about perimeter because fencing goes around the outside. So I'm going to find the perimeter to see how much fence I need. So 206 yards of fence. And then the cost is per foot. So we need to convert this from yards into feet. So I want to get rid of the yards units. I want to introduce feet units. And I know that you can get out your conversion table paper if you need to, but I know that 1 yard is 3 feet. So 618 feet. And then if I know that the cost is $16 per foot, then I need to convert this from feet into money, how much it's going to cost. So $618 feet, excuse me. And then $16 per 1 foot. The feet here are going to cancel. And I'm just going to end up with how much money it's going to cost for 618 feet. So 618 times $16 per foot is the amount of money, $9,888 is how much it should cost to fence that rectangular playground. All right. The cathedral ceiling to a family room creates 2 opposite-facing walls with the shape and dimensions shown in the figure below. I'm going to write 2 of these. The homeowner wishes to have them surfaced with textured drywall at a cost of 59 cents per square foot. So the drywall is going all over this, so that's an area that we're talking about. What will the total cost be for the 2 walls? So this is a trapezoid. We have 2 parallel sides, the base and the base, and then we have the height. And I'm going to go ahead and write these as just feet, not feet and inches. So 11 and 9/12, 10 and 6/12, 8 and 3/12. Okay, so I need 2 of these. Okay, and the area is the base plus the base. So 11.75 plus 8.25 divided by 2 times the height. That's the area, and I'm doubling the area. Okay, so this is 20 divided by 2 is 10. So 210 square feet is for 2 walls. And now we need to find the amount that it's going to cost for the textured drywall, which is 59 cents per square foot. So, and it's going to cancel out the square feet. We're just going to end up with cost. It's $123.90 is how much it would cost. Okay. Last problem. A square hot air duct must have the same area as 2 rectangular ducts with dimensions 3 by 7 and 10 by 6. So this must have the same dimensions as these. What are the side lengths of the square duct? So, same area. So the area is side times side, or side squared. Needs to be equal to these. So I just need to square root this. And then the side lengths needs to be 9 inches. 9 inches by 9 inches would be 81. And then 21 and 60 is 81.